Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. You know what? I forgot. Someone asked a question during the pre-stream, and I forgot to close down the windows, so I apologize for that. We are finishing up some code changes that we made. We did the work yesterday, actually, of finishing the concept of brain code, which is like essentially a sort of self-organizing controllers for our entities. And we just need to kind of finish porting some old code into that structure. And then we kind of need to play with it some more and see if it really does what we want. Because, you know, we have one use case, which is the hero, and we need to kind of build some more use cases to see if it holds up because, you know, we just don't really know. We're in that stage where we're trying to sort of make sure we've got a solid entity system, so we're kind of doing passes over it to sort of get it into a state where we believe that most of the things that we want to do are well accounted for. So yeah, today is day 289. If you are interested in following along at home, unpack day 288's source code into a directory, and that's what I'm starting with now. I'm going to go ahead and load up our Handmade project. Handmade project! I don't know what that was supposed to be. Let me see here. There we go. Chair adjustment as well. So, all right, here is our Handmade project, and we got our brains actually working, which is kind of cool. So we know that everything was correct. What we didn't do is finish porting the hop controller. But for example, the facing direction and stuff like that is set properly now by the brain, and it sets it for both things, which is kind of cool. And so now what we kind of have to do is go through there, and now that we know that the structure of the brain is as it is, we need to start cleaning out that code so that everything else flows naturally from it, and the stuff that should be in the brain is in the brain, and the stuff that shouldn't be in the brain is not in the brain, right? Which is kind of a good rule of thumb for regular brains, one might argue. So anyway, let's take a look at Handmade world mode. .cpp. Okay, so in Handmade world mode.cpp, we have essentially three parts to this code, and we probably, you know, it stands to reason that we might want to make these a little more isolated as well. So for example, we could pull out all the brains into their own file so they're easier for us to know where brains are. And similarly, we could pull out, you know, rendering or whatever, that sort of stuff. So we may want to start kind of pulling these out so it's a little easier to see. And like a lot of people ask me, we get this question over and over, how do I decide when to make new files? It's literally just for visibility. Like when I want to see two things at once, that kind of indicates to me that I want them in separate files. Purely an artifact of the way editing has to happen. It has nothing to do with the architecture of the game at all, and really just isn't very important. But that's, you know, it's entirely personal preference, and you shouldn't feel pressured to split files in any particular way. I would be very suspicious of somebody who told you that there is a right way and a wrong way to divide up your code into files, because that just kind of isn't true. So anyway, I'm going to go ahead and make a new file here. Let's see. I'm going to make a new file for Handmade brains. Let's call it brain. So I'm going to make those, and then I'm going to go ahead and open those up. So, oops, code Handmade brain. All right, and let me go ahead and stick the little header in here in case people are using source code control and want it labeled, which I often do. So, okay. Here we go. Okay. So now I've got my two brain files, and what I need to do now is I need to start pulling some stuff out into them, right? And so I have my entity.h. I could certainly put the brain stuff in here, probably without really causing too much of a problem, because the brain stuff doesn't really rely so much on anything else. It's pretty isolated for the most part. And so I can sort of just grab these and put them out here and say, here's what a brain is, and really all it needs to know is that there is such a thing as an entity, and you might point to that entity, but I don't know that we really need anything else there. So if I go ahead and compile that, what is this saying? Oh, let's see here. Yeah, so I just need to now go in and add those files in so that they can be accessed by the rest of the code. So handmade entity, why isn't it here? Oh, it's here. Okay, well that's fine. Handmade brain.h, so we'll go ahead and build that. And then we also need handmade brain.cpp to be included. Oops. So that's all there is to that. And now I can start pulling out brain code into its own section. So if I take the world mode code, which is what we had before, and I pull it out into the brain section, what I should be able to do is just kind of jump down to where that's actually happening here. Let's see. Run all brains, right? So in here, where we've got this sort of brain execution layer, what I should be able to do is just take this switch statement out, and I should be able to dump the switch statement just as a whole, I think, directly into this file, right? So I should be able to do a thing where this is just like an execute brain. And I don't know if the compiler will actually inline this, but I hope it does, because it's only ever going to get called in one place. I'm moving this out into file just so I can see it more easily at the same time that I look at the individual entity update pieces of information, right? So this is going to take a brain. It probably also needs a few other things. As you can see, it needs like potentially access to the input controllers. It's going to need access to the sim region as well. So there's some stuff in here that I also need to do, like sim region. And then I can go ahead and make this go. There we go. So we'll see what else it needs. I'm just, for now, going to say execute brain. There's my sim region. When I build this, you can see we need the game state, and it looks like mostly just those. It's like the game states and the controllers, and I don't think we really need much else. So we're also going to need, it looks like we need a DT, so we need a DT value, like how much we're going to update by. We need that game state. And I don't know what we actually need for, I guess we just need the game input. And we could do something here where we try to be a little cleverer and we actually only do that input part if we know it's one of the ones that takes input. I don't really care about that, so I'm not going to bother with that. Point being, once we've got that, we can go back to world mode and set that correctly. So here is execute brain. And I'm just going to pass it the stuff that we know it needs. There we go. So heroes exist is an undeclared identifier, which is true. It is an undeclared identifier. The question here is how we want to deal with that. And I've never been particularly good, or I shouldn't say particularly good, I've never been particularly happy with the way that code has been working. It's kind of janky, and what I would rather do is instead of the heroes exist thing, I'd rather have it so that we have a notion, a strong notion, of the world mode having been exited. So I think what I'd rather do is say down here, we get to sort of the end of this situation. And you can see here we have a not heroes exist. I think what I would do is say something more like if world mode exit, or something like that, then we would do play title screen and overwrite it. So yeah, I don't know exactly what we want to do with that yet, but you get the idea. So in here we've got the play title screen switch essentially. Let me see what that's actually doing here. exit seems reasonable. I don't know, we could do exit to title just so it's clearer what it actually means. Why is that? It's not saving my position in that file. At some point I have to look through 4Coder and find out there's a lot of like stuff that slows me down a lot, which is I can't switch between buffers very quickly in 4Coder. It always puts me in weird places or doesn't switch to the last buffer I used or stuff like that. I need to like make that more solid at some point. I just haven't had a chance to do so. Because I noticed it's much slower for me to move around than it used to be. And it's one of the things that I find, like that and indentation are the two things that have been problematic so far. And I think indentation's already getting fixed or partially fixed. So it's mostly, yeah, just one of those little things that I feel like I could probably fix on my own too. So all right, heroes exist is not going to be set to true anymore. And then what I'm going to do is instead of having that concept of like a dead man switch kind of thing there, when we do an exit, right? What I would say is let's just go ahead and keep track of how many heroes there are and aren't, right? And so these brain IDs, we could just say, okay, anytime we exit, anytime there's a hero who leaves, or, you know, I guess what we could even do is just loop over and see if none of the controller heroes have a brain, right? We wouldn't even have to do any more than that. So we could do something where we said, oh, okay, you know what? We don't even need exit to title. All we really need to do is just say that the heroes exist thing that we used to use we'll just set it by looping through the controllers. And so we can also look. Do you see how that did that? See, that's the thing, right? It totally loses where my place is. Like, I used to be down at the bottom of the file, and now I don't know where I am. I'm nowhere. This is where I was. Okay, so in here I've got Handmade World Mode, and I want to look at handmade.h to see where those con heroes are being stored. Oops, handmade.h. And they are getting stored in, here we go. This, I believe, we can now replace as well with max controller count. And so, yeah, in here I can just use the array count of this, of game state controlled heroes. And for each one of these, I can say the controlled hero. I guess I can even just do if game state controlled heroes con hero index dot brain id dot value heroes exist equals true break. Heroes exist needs to get heroes exist needs to get here quit requested. Does that do anything? No. Okay, oops. I think we're all good now. Okay. And this is still running for some reason, even though I would have expected to crash because we changed the data layout, but I guess it just wasn't because we just added something in a place that it didn't matter. It was fine. Anyway, so now we kind of have the brains pulled out to a separate file, and here is that file, and you can kind of see that we've got some stuff in there that we need to start working on. And then down here we have what is now sort of becoming the physics part of things. So here's all of the controller logic. So this is like if we have anything that's thoughtful at all. So a monster or you know monster AI or any of that stuff can run up in here. So we've got this where we're going to run the brains. We can then say like, okay, now we can come in and deal with all the entities. These entities should have had stuff set on them. You get the idea. We have the notion of updatable, which we can still obey, although I think that might be something we eventually can get rid of now, based on the fact that we're room locked and not free scrolling anymore. We really just have to worry about this one little part of the boundary, which we can talk about sometime later. But assuming that entities are updatable, we can kind of see what's supposed to happen here. And so what we want to start doing is cleaning up this code into something that works reliably for all entities that need to, be updated. Now, here in this post-physics entity work side of things, you can see that all of this is actually just rendering, right? Like this switch statement does nothing but render a dude, right? That's all it does. And so I don't really know exactly how we're going to handle that. We're going to have to look at that in a little more detail very soon now. But basically, we're going to have to start wondering about how entities look. And that's going to have to be derived from their properties in some ways that are complicated, right? Because like I said before, we kind of want to have the ability for entities to be fairly freeform and to kind of morph into various things. And that's going to put a bit of a stress on the way that we match, figure out what bitmaps to draw. Because obviously we only have a finite number of bitmaps, so we can't just create bitmaps whole cloth. If everything was completely procedural, we could, but that's not really feasible for the case of a sort of hand-drawn look kind of game like this. Maybe someday in the distant future it will be, but not today. So I don't know, a lot of this stuff, I don't really know if we want much of this in here. I feel like this kind of needs to get moved out of here so it's not bothering me anymore. Let's see here. Put this down in here. There we go. All right. And so we can kind of see how this works. All of this stuff is simulation based. We have these sort of separate waves. And each wave corresponds to something that we're trying to do. We have the brain phase, which goes through and decides what to do. We then have like a physics phase, which moves things around, and then we have an entity phase. And I don't know that I care super much about this timing block, so I'm going to go ahead and flatten this out. Again, I'm just trying to flatten this out and start to think about how it's working and simplify things where possible. So here we've got run all the brains, and I don't really need this comment anymore to be quite so big. Let's see, run all brains, and this is simulate all entities. All right, so now what do I want to do here? Well, this stuff is sort of a mix, right? It's a mix of rendering and simulation. You can see that it does a switch on the entity type here, and it does the actual movement code setup, and then it does a switch on what the movement type is and does the movement sort of separate from, it doesn't matter what entity it is, it'll do the same movement code regardless. And then it comes down and finally does the rendering, right? Like essentially this should not be called post-physics entity work, it's really just rendering, because that's the only thing it does at the moment, right? You can see that there's really nothing else that's happening here besides that. Let me delete all this, we don't need this anymore. Yeah. So this rendering code is something that we'll get to later, so I guess I don't really have to care about that too much at the moment, but we're going to have to start thinking about it soon. So I'll leave that for now, and we'll just focus on this. We'll focus everything up to this point. Okay. Here is the move entity code. It's the code that gets called whenever an entity has to actually go somewhere or do something. I don't really know if we want this movable flag anymore. I suspect we probably don't want the movable flag anymore, and the reason I suspect that we don't want the movable flag anymore is because the way that we're doing entity motion now is much more semantic, and I suspect that pretty much you could just have your movement mode be set to not moving, and that is good enough. Like, we shouldn't need a flag in addition to an enum that says how you're moving. One of the ways in which you could be moving could be not moving, right? So I suspect we could get rid of this flag pretty soon as well, and that's something I'll probably be aiming to do in a second here. But what I'd like to do is go back and take a look at some more of these things and just make sure that I kind of know what's going on here. So you can see that we've got DDT Bob and we've also got DDP are the two things we're setting. I'm going to go ahead and say that this right here is a paired thing. It has to do with the head distance from the body. And so in my mind, this is a brain operation, right? This is an operation that has to do with things when something's planted stretching towards its like related entity, right? And so what I want to do is say, well, if the movement mode is planted and if there's a head, then we're going to sort of, you know, have this notion that this stuff is going to occur, right? And the difference here is that when we compute this DDT Bob, that's going to be the DDT Bob for the body. We're going to write that into, you know, into the DDT, okay? Because otherwise we do have this other notion of what the DDT Bob is, right? We have that being able to happen in other ways, right? It can happen inside one of these sort of hopping movement things. And so I'm just going to say that that's something that happens as an accumulator, right? And then later we apply what we need to apply to the DDT Bob, and then we, you know, we would zero that out on packing because it would go away during packing, right? So essentially I'm doing the same thing I did with DDP. There's now on the entity, there's the notion of acceleration stored on the entity, but only during the time when it's actually simulated. We would never actually store it, right? It's not something we would store and keep around. So here's my DDT Bob. And again, this is probably not something we'll keep, but we just want to, we're going to have values like this, and we would have, it's probably just not called DDT Bob, but we would have this notion that, you know, certain bones have some springiness and other things like that, right? Okay. So what we need to do in additional, as an additional step here is things that we don't want to pack, right? We want those things to not persist to the next round. To the next update cycle. So inside world, when we are actually packing entities, what I'd like to do is just, you know, sort of prophylactically, so that we don't get in the habit of keeping them around or aren't confused when they stay around, I'd like to go ahead and clear the things that are not supposed to be stored, okay? Just to keep that going. So now in here, yeah, we don't really have to worry about a lot of this stuff. Because now we know we've got two things, both the head and the body. So in this case here, I could say, like, if I've got the head, then I know that my head distance is going to be that length, and it's the length between the head and the body. And that gets rid of all that complexity as well. Okay. So now I think we're still in good shape. Again, we haven't fixed our DDP yet, but we're starting to clean that up. So I think that's the last thing we've got to do. Is actually get the DDP part correctly, which is what allows entities to move around. And what we had here is we had this notion of this movement spec. And while the movement spec is not necessarily a bad idea, I think it is a bad idea that it's not stored on the entity. And the reason that I think that is because, again, much like the DDP, it's something that a bunch of people may want to feed into and operate on. So what we want to do is we want to have some notion of how this movement mode stuff works. And so let's take a look at that. Oops, I'm actually up here. So you can see what used to happen when we would set these movement modes. We had this movement spec that was here. It was getting set this way. I strongly suspect that we want to kind of clean up how this movement spec thing works at all anyway, like the speed and the drag and this crap. I don't know that we want any of that anymore. I would be shocked if we really want this to work exactly the way that it is working. But, you know, that's all right for now. Not a huge deal. The point is, what I'd like to do is take a non-packed movement spec and add that to the entity. So the move spec here that we've got where we do default move spec, what I want to do there is say, okay, the movement spec on an entity, you know, there's going to be one. Put it in here. For now, we'll just say there is a movement spec. It's not packed for now. And so what happens when we go to update is instead of getting the movement spec from here, we're not going to do that at all. Instead, we're going to get the movement spec out of the entity itself. And so later when we come down into the movement stuff and we say, let's go ahead and move it, what we actually are going to do is we're going to get that out of the entity. So if I go back now and look at where we were actually assigning that, there were two places we were doing it. One was for the head, one was for the body. Oh, well, that's not true. Looks like one was for the body. Where was the head? Did we never do the head? Did we ever even use this? If we don't use it, I'm just not even going to bother with it for now. Because I don't care about the familiar at all right now. Interesting. Is it in here? So I guess we never really used it for the head, which doesn't make any sense because we would have had to use it for the head in order to make the movement work. So I must have just deleted the code that used that or whatever. Anyway, I don't really care about that because I want to apply I really don't want this to be doing anything fancy anyway, I guess is the point. So, you know, we'll use this for the moment and we'll just say, okay, hero body I don't care about, but hero head, right? So if there's a hero head, I want it to use whatever this spec is, let's say. So we're just going to go ahead and say head, like so. I don't know where that actually gets defined. Here it is. But that's gonna, I think we're gonna, I don't like that system at all. I don't really like that. I think it's not gonna scale well, like having this movement spec concept. I think we want to make it a little more of a functional thing. I don't know. Maybe I'm wrong. Maybe it'll be fine. But I'm not super confident in it. Let's put it that way. All right. So the familiar, I'm just going to if zero this out because we haven't really talked about the familiar much. All right. So let's take a look at what this is starting to look like now. And let's see if we can get, so I'm not getting any DDP in there. Let's see if we could figure out how to start routing the DDP into it. So here's the brain code. And in the brain code, you can see me setting the DDP here, right? And that's sort of the controller's requested DDP. We then take a look at what that is, and we're doing like some kind of a fussing on that, I guess would be the way to put it. And then we're adding to the head's velocity just straight up, right? The head's velocity is just getting added directly. Which is kind of a little bit weird. Yeah. This is what happens when you have to make too many code changes at once and you have to spread them over weeks of time because you only probably program an hour in a day. You kind of forget exactly why you were ever doing something one way. But that's neither here nor there. Excuse me. Okay. So if we're looking at the hero head, excuse me, it looks to me like since get closest to versable will always work in the case that we're looking at now, it seems to me like the head DP should always actually have a value added to it, right? And this doesn't really look like what I would have wanted to do, so I feel like I'm just going to stop this from happening entirely, because basically the head's DDP should be equal to this acceleration. That's what we wanted to do, is set an acceleration for the head. I mean, that's just what we're trying to do. So now I want to kind of figure out why are we not getting any sort of movement here. So I just want to see what happens, and I should probably also come in here and say, let's put that in for now. I want to make some major changes to this code, but we don't have to do that right And so now when I'm pushing on things, I want to know why I'm not getting any actual acceleration there, which is a little bit harder to do. So what I'm going to maybe do here is maybe I'll just add a force so that it's like permanently pushing to one side, so that I don't have to try and hold down a key and then hit a breakpoint or something like that, right? I guess I can use was pressed. Oh, I see what the problem is. For some reason, we have was pressed and not was down, right? So we actually were using this as a state thing. We actually were storing the controller state in the con hero, right? I forgot about this. We were doing some stuff to make it so that it would remember what the last direction you had pushed was. All right, I liked that. I felt like that made a good difference when we were... I felt like that made a reasonable difference when we were playing around before. So I think I may leave that there, if that makes sense. I think I may say, like, okay, that's a reasonable thing to keep in the controlled hero, is like what the controller state was supposed to be. And so I guess maybe we'll call this controller dir or something like that. I don't know. DDP makes it easier to type, even though that's not quite what it is. So I'll delete this one here, and I'll say DDP equals con hero DDP. And we're going to have to figure out how we want to do analog stick motion as well, right? Because I don't know if we want to use some cross, like make a nice cross-shaped dead zone pattern or something, so that you kind of, it locks into whichever one you're pressing more into. I'm not sure. But something like that probably has to happen at some point if we want to support analog sticks as opposed to just D-pads. So let's see here. So going through, we've got length squared con hero DDP. And I think that's all we need. Oops. What happened? I don't know what I just did. Oh, right, I changed the data layout, so we got to restart anyway. All right. So now what I'm going to try doing is I want to make sort of a pass through the code to find out exactly why we're not getting the DDP. I want to step through the code and see how the DDP is ending up getting set. And I just want to do that before I start factoring this code to make sure that we don't have any other bugs. Well, I'm almost certain we do have other bugs, so I'm just going to get rid of those before I start playing around with the code. All right, so inside brain, which is not here, unfortunately. Open file. Brain.cpp. All right, so what I'm going to do is I'm just going to set a breakpoint on move down. You know what? I'll do move left. All right. So it'll be x equals 1, the easiest case to look at. So here we are in that piece of code. Visual Studio's thankfully picking up a key press that went to another application and starting to insert characters. It's almost certainly what you want in the middle of a breakpoint. And here we go. Looking through here. Looks like we don't really have anything particular to care about here. But here is the code we actually do care about, where we're sort of looking at this DDP. Okay, so if we take a look at the con hero DDP, we see that it is x1, which is what we expect. We come through here and, we should, in theory, not zero too much of it out. Our DDP2, well, that explains that. Because that's not correct at all. Our DDP2 never gets set here, right? And it should. So DDP2 actually should be equal to this directly, I think, is what we should have been doing. Right, because we should have set it to what the acceleration is. So I think that's the mistake. or not. Right, because this is clipping out the elements of it if, you know, when there's no push happening. But otherwise it's passing it through, which is what we want it to go to head DDP. Right. And we're using that DDP, are we not? Or did I never do that either? Which would be yet another thing that we didn't do when we were fixing up the code. Yep, we didn't do that either. That's got to go away. So DDP for entity type familiar, this can be the entity's GDP for now. We're going to probably move the entity familiar code over to a brain, though, obviously, right? And so that'll be fine. Here's entity DDP. All right. So we're not really in a correct state yet. We still got a bunch of stuff to do, but at least now we're back to being able to move our head around in the way that I would have expected. So that's nice. All right. Sorry, I've got itchy eye. It's a bit allergy-ish in Seattle these days for me. I don't know why. I don't think the allergy season is really that high at the moment, but plants. All right. So now what we need to do is start to kind of clean up this code a little bit more. You can see that entity type is now starting to get very spare, which is what I wanted, right? Because I don't really want anything to have to do with the entity type anymore. So one thing we could do is now say that the hero familiar code moves over here as well. And so I don't know that we really want anything in particular to be called hero familiar yet, but I'm going to do that for now just so we can sort of see that, well, whatever it is that has that sort of stuff related to it, it's going to be over here, right? So all of this stuff is going to be over here. And so now, and then in theory, that floaty thing for now code would, I guess, also be a piece of brain code, right? That was like moving things around. So even this would be a brain floaty thing for now. Because anything that's like a behavior is going to move over here, and they might not be specifically brain IDs. They may be like, it may be like the brain ID is like an animated piece of scenery is the brain type, and then there's properties of the entity that sort of tell it how it moves, right, or things like that, if that makes sense. So now this entity type stuff is not going to be determining that anymore. And maybe we use this and maybe we don't. And now this goes away. And we really just have the movement code, right, which is how entities move, and then the rendering code. I'm going to go ahead and grab this and put it down here. All right, so now we've got to actually define those brains, which is fine. And then anyone who was previously using the entity stuff, you know what, I need to start keeping track of the four-coder things that we run into, because I don't ever keep track of them. Like buffer position loss, etc., etc. I gotta start making notes. Things don't get better if you don't make notes. All right, so in here we've got this entity stuff. I'm not going to port the familiar just yet, although we probably do want to do that soon. Let's see here. All right. Okay. So let's go ahead now and start to think about, you know what I'd like to do is, before we clean up this brain code anymore, what I'd like to do is actually come over to the entity stuff and see if we can now consider a way to... I'd like to figure out some way to get rid of that entity type, right? Because like I said, one of the big things I wanted to do was not have entity type be a thing anymore. Like I don't really want that, right? And so I would rather have ways in which an entity itself just says that it's made up out of some pieces. And so when it's created, it can just be made up out of those pieces, and then off you go. And there's really not much more to it than that, right? And so you can see that that wouldn't be probably that difficult, because you can see that all we're doing here is like pushing bitmaps on for like, you know, we're just doing some asset matching and then pushing some bitmaps on. And so it seems to me that we should be able to have a way to make that work without a whole lot of, you know, of to do about it. And I feel like probably we could say that, you know, in general, things are made up of a couple pieces, and that those pieces, you know, have sort of a known way they get rendered, and that we don't need to base it on the type at all, right? That seems reasonable to me. Stairwells are not a thing anymore. Those just don't exist. So I don't really want that. We can get rid of that entirely. Monstars are a thing that would exist, but they're going to be a brain, probably. Let's see here. So we've got the Monstars, and a Monstar was really no different than a regular hero, but just with a torso. That's all it was, and presumably we'd have other stuff in there. Floors and floaty things, those are like just solid pieces that are on the ground. So again, I feel like all this stuff, let's just do it. Let's do it. I'm in the mood to get rid of this. I don't really want any of this crap here anymore. So here, this is just debug code, right? So this can just be, anyone can have this drawn, right? Anyone can draw their traversables and their collision wrecks. So let's just do that, right? Let's do that. And so that just should be like a bunch of, yeah, there should just be a bunch of squares on stuff, right? Yeah, there you go. And so we'll just make a debug switch or something that controls that, and then we don't have to think about it anymore, right? So that's fine. So now we don't care about any of these entity types at all. And then the rest of these, like I say, most of them are just like, okay, do I have a shadow? And then I've got some, like, do I have any springy parts that are sort of associated with each other? It looks like it shouldn't be that complicated to me, right? Seems pretty straightforward. Yeah. All right. So in here we've got. I don't know why color. I guess we just have. Oh, because we were doing some kind of the bouncy offsets for the hero's body. So what I'd like to do is just, let's just take this code and just make a sort of a smushed down version that every entity could use, right? And so the entity familiar where the head bobs up and down, right? That can still be the same as how like how the torso bobs up and down, right? Those can all be essentially the same because the torso already has this notion of that it can come up and down. I'm sorry, the cape can come up and down based on the T-bob. So really these are the same, if that makes sense. And we don't really need them to be dealt with separately. So for, you know, if this were something that were going to be animated, then that can just be something that gets generically animated, and it's not really a big deal. So we'll figure out how to do that. The Monstar is completely the same as the hero, it just didn't have a head, right? Drawing hit points seems like something that everyone could have happen, and then if they just don't have hit points, then we just don't draw it. So I feel like that's also something that could come down here, and we just make that a little bit smarter to just look to see whether there's any hit point slots, and if there are, we don't draw them. In fact, it looks like that already works, right? Because if you don't have hit points, you don't draw the hit points. So now anything could just get hit points all of a sudden if it needed to, and that would work, which again is more keeping with what I want. I don't really want things to have types that define these things. I just want them to either have it or they don't, and then not have really any cost to just making something suddenly have them. All right, so the hero head, if I was to sort of add these together, let me see what happens here, right? The hero head, again, could just be in place of one of these guys. So really that concept of a composite where we just have like a shadow, a thing, and then the thing on top of it would draw everything that we have at the moment. So we could just do that. I don't know what this 2.5, so these are the heights, right? So let's just make this a property of the entity. So in here we've got these entities, and maybe we've got sort of the notion that each entity sort of has a component, right? And I don't know what we'd call this, but like a visible piece, right? And this visible piece would just be, I've got, essentially the things that I use to call this bitmap call is what I actually want, right? I have like this sort of stuff. So I need to know what the asset type is. Like, what is the asset type that I'm grabbing for this thing? I need to know, like, I suppose what the alpha value is for it, and maybe I don't really want to know that, I'm not sure. But, probably I do. I need to know the scale of it, so how big it is, probably, right? Just this way, like height, basically. And I guess we could just call that height. So I need to know the height. And I need to know the color. I could just say v4 color, right? And then I need some information about how they're going to be matched, right? Because, like, I guess I could just put the facing direction in there, and then, well, I guess that's really all I would need, is just to throw in that. Yeah, I mean, I don't know that I really need to keep an entire weighting vector in there. I think we could just get by with this just for now, and probably most of these things would work okay, right? And so then here I can just say, well, I've got a few of these visible pieces, right? And, at the moment we're basically saying, we can't really have very many of those, and I think I don't ever probably want to have too many of those because, really this is just for animation purposes. If things were actually moving around very distinctly, then they should be separate entities. So this is only like for animation. These are animated pieces of this thing. And so for now, it would just be something like that, right? Now, possibly in the future, we may need to do something where these are shared. And in fact, now that I think about it, that might be something we would want to do in general. Just because we don't really need to store them if they're usually the same, but I don't know. I think I'm going to leave it this way for the moment. Yeah, I think that's probably how we're going to leave it. All right. So if we have these visible pieces, and then I'm going to draw them, I could basically turn this thing into a loop that works that way, right? We've got the entity x-axis, the y-axis, and the floor displaced and that stuff. we can essentially use this thing and just make a loop that would look this way. And we would just need some extra information. How much time do I have? Not a whole lot of time. I really just need a little bit of extra information to do some of these more advanced things. So I'm going to leave the hero body out of this for now, and I'm going to do the rest of these because they're a lot simpler for me to start with, and then once those are working, we'll figure out how to back into making the other ones work, right? Okay. So let's start with the easiest one, which is the wall. So if we imagine how this is going to go, I can just say, okay, there's a piece index equals 0, piece index is less than the array count of the NV pieces, piece index. Oh, wait, no, it's not. I guess I can just say piece count, because it has less than that number often. And then I have an entity visible piece. And I'm just going to do that drawing. So I'll do a push bitmap. And I want to do a get best match here. And so I'm going to do a get best match for the bitmap ID. When I do the get best matching bitmap, I need to take the piece asset type. Oh man, I can't actually get any more room, can I? That's unfortunate. The asset type, the match vector, and the weight vector, right? Once I have that bitmap ID, that's the one that I'm going to be passing here. I know that the piece height goes here. I know that the piece color goes. Wait, no, this is the offset, I guess, right? Which we haven't really done anything with yet. So then I would have here, I'd have the piece color, like so. And that'd be the simple version. Right, so that's pretty good. So now I just need to actually set one of these. And so, for example, for wall, I could probably make this happen right now. So if I go up here to where we would create a wall, in add wall, oops. Yeah. I can go ahead and add the entity piece here that correctly represents this thing that I'm trying to draw. So here's me doing it first without that. Is asset type not known at this time? Somehow? Does entity come before asset? That seems weird. But possibly true. Let's find out. Because file formats, it would be in file formats, right? And entity's way down here. It's asset type ID. That's the problem. There we go. So now when I run the game, I'm not going to see any walls, right? So I know they're there because their collision volumes are there, right? But I don't see them. So what I need to do now is I need to actually get one of those. I need to actually make a piece for the, that says a tree has this one component, that's the tree, and you should draw it, right? So if I go to Handmade, world mode.cvp, and inside add wall, what I need to do is do an add piece command, which will create, which basically says like, hey, it's going to be an asset tree, it's going to be 2.5 tall, and it's going to be, well, we don't have an offset yet. I suppose I should have probably put an offset in there, but it's just going to be white, right? It's not going to be tinted at all. Okay? So hopefully you can see what I'm doing here. I'm doing a very straightforward process to get this started. I'm just saying, okay, let's make a sort of a data layout that just mirrors what we were actually doing, so that I can make it so that entities prescribe in the actual entity exactly what will happen when they go to be rendered, so that each entity can have a unique way in which it gets rendered, as sort of like, it's basically like taking, and it's almost a mini scripting language kind of approach, right? When you do this sort of thing, you're saying, I'm going to add a bunch of records which say the functions to use, basically, and they just happen to be based on very specific parameterization, so it's a very limited way of scripting it, right? So you're basically compressing some ideas about what code you could call into just a few parameters and then unpacking them that way. All right, so in the add piece call, right, pretty easy how this works. I just say, all right, I've got an entity. The entity has an asset type ID. I'm sorry, the piece has an asset type ID. It's got a height, and it's got a color. And that's a simple way to add a piece. We would assert, of course, that the entity piece count was not too full. And then we would just say, fill out exactly that piece. So entity visible piece, entity pieces plus entity piece count plus plus, piece asset type ID, asset type ID, piece height equals height, and piece color equals color. So that is all we need to do to add a piece. And in theory now, also, we probably can render this, right? What is it? It's not a member. Oops. Probably don't need the ID. All right. We're at the Q&A, but hey, you can see that we've restored that functionality, so now we have trees. And of course, since we are now doing that, it also means that if we wanted to, right, we can use the world mode's random series, which I believe is in here, right? So we could use like effects entropy, and I'm not really going to do this, but you could imagine doing it, right? If we wanted the trees to have a random amount of red in them, right, we could do random unilateral on the effects entropy. And now every tree would be like a different color, right? At least in or not. I would have expected each tree to be a different color. We are using that, are we not? We might not be. Now that I think about it. Piece count. No, we are. So we're passing the color here. Why are we not seeing that be... because there's no red in it. Yeah, that's a good point. If there's no red in the tree, you won't see that. So let's take that again and say a random amount of green in it. That's probably a little bit more obvious. Oops. Yeah. Even just so you get some idea of what's going to happen there, you can see why we might care about this just even right off the bat, because we're going to want to have lots of different trees in the game, but they don't have different entity types necessarily. And so, having the ability to just say, like, this is what we're creating an entity, here's how it behaves and what its stats are, but its visible representation might be slightly varied just so that things look slightly different all the time, right? You can see why that might be important. And so there's a lot of things like that that we might want to do, and this is just one step towards doing that. Yeah, so like I said, just kind of a nice additional thing. Now, I don't actually want to do that right now, but I just wanted to point out how that changes things. All right, let's go ahead and go to the Q&A. I think that's funny. It's like, yeah, it doesn't matter what the red channel is on the trees. There's literally no red in those trees. So you can knock it all the way to 0 and you're just removing stuff that wasn't there. Any questions? Looks like we don't got no questions. Which is okay. If we don't have any questions, then we will end the stream. This is coming along pretty nicely, I think. There's only one thing I'm slightly nervous about, and that is how we're going to do boundaries of the simulation region. Everything else is pretty nice. Recently came across this. Read the abstract and tell me what you think. Programmers hoping to achieve performance improvements often use custom memory allocators. This in-depth study examines 8 applications to use custom allocators. Surprisingly, for 6 of these applications, state-of-the-art general-purpose allocator, Doug Lee's allocator, performs as well or better than the custom allocators. The 2 exceptions use regions, which deliver higher performance, improves up to 44%. Well, obviously, I probably agree with the results because, like, Handmade Hero uses regions. Regions also reduce programmer burden and eliminate a source of memory leaks. Exactly what I would say as well. However, we show that the inability of programmers to free individual objects in the regions can lead to a substantial increase in memory consumption. That's generally true. If you depending on the type of application it is. Whereas this limitation precludes the use of regions for common programming idioms, reducing their usefulness. That I don't know if I really agree with, but okay. Percent generalization of general purpose and region-based allocators we call REAPs. REAPs are a combination of regions and heaps, providing a full range of region semantics with the addition of individual object deletion. We show that our implementation of REAPs provides high performance, outperforming other allocators of region-like semantics. We then use a case study to demonstrate the space advantages and software engineering benefits of REAPs in practice. Our results indicate that programmers needing fast regions should use REAPs, and that most programmers consuming custom allocators should instead use the Leah allocator. So I guess I'd have to read what their implementation of REAPs, quote unquote, is. But for the most part, I agree with the abstract. Because in general, like, that is why I use regions as well. I find them to be faster and less error prone than allocating and freeing individual objects. I find that I just use free lists when I need to recycle objects. But certain applications that are not video games have more strenuous need to free things in that way. And so it may be that they've done something interesting here with how they do it, or it may be that they're just doing something that's like exactly what I would do, or that is a free list essentially. And so I have to like read to find out if it's something to talk about that second part of it. Does that help? Is there a limit to the colors you can have? Well, I guess I'm not sure what you mean by. I'm not sure what you mean by limit. There's not a limit to the colors you can have in terms of sending. Could you be more specific, I guess is what I'd say? Because there's a number of ways I could answer that question, and the answer is yes in some cases and no in other cases. And so I want to kind of understand what question you're trying to ask before I say things that may be further confusing, maybe more confusing than helpful. Long Boolean, will you have to have an entity type at some level, like when generating the world, placing trees and whatnot? I would say that I don't know if we'll have an entity type per se, but when we're generating the world, we'll definitely have ideas about what we're placing, and that might come from a type, but it may instead come from just the structure of the code. Right, like this thing is going to go place trees and it calls the place tree routine, which knows it's placing trees, and so there was never maybe a need to have a enum, right? So I guess what I'd say about that is I don't know whether we'll ever use those enums again. We may delete them and then never come back, or we could, if they end up being something we do need to use in the generator side, then that's fine. I don't mind them in the generator side, right? I just don't want them in the runtime because I don't think they're the right level of control. Waiting for a clarification on that limit to the number of colors question. In the meantime, I'm going to see if I can quickly look at this Reaps paper and see if I see what their structure is for heaps. Boy. So I guess what I would say is what they're describing in this paper does not sound all that different from how I structure things in like my code at work, except for the fact that they seem to have added a lot more overhead than I think is warranted. Because I find that most of the time, I feel like they were probably trying to target a lot more oops-y code than mine is, and so they probably were trying to accelerate cases where people were doing a lot more malloc and free than I ever do in the course of a running program. And so they were probably chasing after performance in areas where I just don't need it. And so I feel like they add a lot of memory overhead here that I don't think is necessarily warranted. Now that said, I haven't spent a lot of time optimizing memory performance in my code because it's almost never an issue. So if someday I actually took a harder look at that just because, hey, it'd be fun to try and get it more optimal just as an exercise, I might have a little bit of a better idea as to whether I think that level of overhead they're talking about is warranted, which I don't really know. Okay, so clarification was colors of the trees, the hero, enemies, etc. Again, I really just don't understand the question. Like, what do you mean to say, is there a limited number of them? Do you mean, does the game design have a limited number of colors that trees and heroes are supposed to be? Or I'm sorry. I think I'm missing like the sort of place you're coming from. Ingeniero, I've been a little lost the last few days. Would you mind giving a brief recap of what you're trying to do to the entity system now? Yeah, so the overall idea here is to split out the parts, the things that make an entity actually appear on the screen and do stuff, to split those out into reasonably separate elements that can be recombined very fluidly, right? And so some things that I wanted to be able to do, for example, was say, oh, if I have like a hero head and a hero body, I want to be able to write some control code that can make the hero head and body move around. But I don't want there to have to be an understanding that heroes are always constructed of a head and a body. And furthermore, I might want to be able to like put different bodies on a hero or, you know, do stuff like that dynamically without like having to sort of copy things between entity. I want to be able to just swap in a new piece and have it start working. Furthermore, I'd like to be able to do things like cast a spell and make a hero behave a different way and then later behave, you know, or whatever. I want to sort of have a very rich way of doing all that. I don't want to have heroes always have to look the same way. I want them to be able to have like different outfits on or stuff like that potentially, blah, 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 right? And so the way that we'd implemented it in the beginning, because we were just sort of getting things working and, you know, we're coming back to revisit it now and I'm trying to do the real version of everything. The way that we did in the beginning is we just said, hey, entities just have a type, and whatever the type is, that's what determines everything, right? And that type, there was basically just some switch statements that were like, whatever your type is, that's what's going to determine the code that we call to control you. It's what we're going to use to determine how you're rendered. It's what we're going to use to determine how your physics operates, right? And so I'm just trying to get rid of all of that and say, no, there's just an entity, and an entity has lots of little pieces of information that sum up to reproduce all of that stuff that was previously hard-coded to an entity type. But now you can mix and match. So if you want something that's being controlled like a hero, but that looks like a tree and blah, 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 you can do that, right? The reason that I'm doing that is not because I think there's some inherent important beauty in writing an entity system this way, and if you have entity types, then that's bad or something. It's more that this particular type of game is sort of a generative, sort of explorational, adventure-y, rogue-y kind of a thing. And as you know from having played the good ones of those, they're a lot about having rich permutations and interactions between things. And so I really don't want to have hard edges in that space where it's just like thing is either an A or a B. I want like everything in between A and B to be fair game. And so that's sort of what we were trying to do there, right? Thoughts on avoiding denormalized floating point on console platforms? Do they all have -F fast math? Well... So I guess what I would say is it depends on what you mean by console platform. But if what you mean is Xbone and PS4, then an Xbone and a PS4 are x64. So they operate through the SSE unit for doing math, which means you can just not have denormals at all. So you don't really have to avoid them, they just won't happen. Because you can always have the SSE unit just never do denormals handling. To be honest, I don't even know if the SSE units on consoles do handle denormals. They may just always denormals go to 0. I mean, I've never looked. Nietzsche, my apologies. Yes, limits in the game design. Yeah, so the game design definitely will want to have specific colors that mean certain things, obviously, in various places. But small variation in color will probably be something that we would actually use just to add a little more variety to things. So we probably wouldn't limit that. We would allow things to sort of have color variation. Anonymous 519, can you explain the difference between how you manage memory at work and how you're currently doing it in Handmade Hero? Not really, because it's kind of a long story. Will monsters and other things be able to attack each other, like a witch accidentally shrinks a goblin or something? Yes, probably. To be honest, I don't feel comfortable saying yes or no till we actually let it happen and see if it's too chaotic. But I certainly would default to yes in that case. Would we do anything differently if we wanted to have HDR capabilities in the game? We would probably have to add a few values in some places to allow colors to be more powerful than they currently are. We could just say that colors can be set more arbitrarily, but typically you don't quite. Typically, you might do things where you have like a power value and then a color value. So there's some things you might do, but not really. No, most of it would just be that the renderer would be taking tone mapping, would be doing tone mapping and taking that side of things more seriously. Realist01, can you answer my previous question? People would like to see your pre-streams on YouTube. I've answered that so many times by now, but I'll answer it again. The pre-streams are only for people who watch the stream. That's... If you want the pre-streams, you gotta watch the show. They're not for posterity. Let's see. Anonymous 519. The reason I ask is because I really like the idea of allocating upfront and managing all memory myself as in Handmade Hero, but I'm not sure if I'm just shooting myself in the foot by not using malloc and free. So I guess what I would say about this is you should be able to think this through relatively straightforwardly, right? So in Handmade Hero, you know that everywhere that we're just doing a push and we don't have a free list, there's no way you would ever want to use malloc and free for that, right? Because it's never freed. It just gets push, 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 which is essentially an instant operation that malloc can't even come close to being as fast as, right? Because it doesn't do anything. It's an add, right? And then free just goes, okay, we just reset the pointer. So you know that anywhere that your stuff looks like that, you would be crazy to use malloc and free because that is just clearly always a win. Once you start having a free list, so now you don't know, right? And I should add one caveat there. Typically what you would do in a more general purpose scheme is you don't allocate everything up front. You just allocate when you overflow. So you just push, 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 push. If you're about to go over the end, you just get a new block and keep pushing, right? So that you don't use more memory than you need, right? So that's what you would do. In the case where you have a free list, it should be relatively easy for you to think through, in the places where you have a free list, is this faster with malloc and free, or is it faster doing the free list approach? And you know what? Don't hurt yourself thinking about it. Just do an if zero. Just put an if def in there. Make it so that you can call malloc and free or your free list version, and see which one's faster. That's it, right? You won't have that many free lists in a program. It's not that hard to test. You could even make a centralized thing. Part of your allocator could just build in that switch and then just turn it on and off. Done deal, right? It's always free to switch back to malloc and free, right? The only thing that's hard is if you're counting on that region free, and I don't know how you really solve that problem. If you're counting on the region free, switching to malloc free is a little hard because you don't clean up, but you could still at least test it, and then you don't get the freeing, so you can't really run the thing indefinitely, but you could at least test it to see if you got a performance win there. And then if you did get a performance win with malloc and free that you thought was important, you could then go back and go, okay, how do I deal with the fact that I've got to like free this stuff manually now? All right. I am going to wrap it up. All right. Thanks everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, so you can do whatever it is that you're going to do. So you can play around with it basically, and see if anything that you want to try, and it kind of helps learn along with the series. We have a forum site you can go to ask questions. We have a Patreon page where you can go if you want to support the video series. We have a schedule bot that tweets the schedule when I remember to upload the schedule, which I didn't do this weekend, so I apologize for that. I did upload it yesterday, so now it's correct. And of course, we got this little countdown timer here that tells you as well. And then we have a past episode guide, which you can use if you want to catch up on old episodes. It's pretty cool, and our very own Miblo has made it so that it's got all kinds of time links in it, so you can jump around and like go, where did Casey talk about this thing or whatever, and it's pretty cool. That's about it until tomorrow at 5 p.m. Pacific Daylight Time, when I will be probably finishing that, sort of moving the rendering out to that sort of piece-based creation time system. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.